Hi guys, right, so making a timing belt. I've done one already. Uh, I wanted to find out all the. Well, the last bit went really easy, ish, putting it all together. But some, sod's law. At one point, it's going to get an issue. So yeah, right. A timing belts. Now, timing belts have to be tensioned correctly. Otherwise, they'll override the bits. I don't know if I can show this, but if you have a slack timing belt, basically what happens is that the radius around the teeth gets bigger because the timing belt can actually get. Have a look. Yeah, the timing belt can actually sort of get bigger like this, and if it gets bigger, then the teeth spacing on the larger radius of the belt is different from the teeth spacing on the other one. So that what it happens is it ends up riding on the thing. So you've got to have the right tension to make sure that it is actually pulled into the right radius when it's actually hitting the wheel. Which I've got that. So this was not an issue. This wheel was not an issue. This is perfect. But this one was. Here's the other wheel. Now let's see if we can get. I just want to zoom in on this. Now then, where are we? So let's just go to ×2. See if we can get it to focus on that. Now then, I don't know. Can you see? Like I say, it's 3D printed, and what you have to remember is, even though we've drawn nice square teeth on there, there might be there'll be the correct space apart, but they're obviously rounded because the filament coming out of your 3D printer is round, and it's 0.4 mil thick diameter. So we've only got 1 mil width. Well, it's actually less than 1 mil because I want a bigger gap than a tooth. So it's about 0.8, which gives it can come out once and go back in once, which is because the filament is 0.4 mil wide. 2 times that is 0.8, so it works out just right. So you've got to remember this as well when you're drawing teeth for a tooth wheel. You've got to think of what you're printing with, like. So you've got to make the tooth multiples of the width of your filament. If you don't, it's going to make a mess. And also, I want to show you what you're printing is not what you've drawn. Let me just try and explain that as well. So just give me a minute to set up. Right, so when we draw it in CAD, in FreeCAD, it's all nice and square, our teeth there, look, all square, flat faces. But then we export this to an STL. So we export that to an STL like so, and we've got this one here, STL. And then once we've got that STL, that then goes to, I use Cura. And if we look at, well, before we look at Cura, let's just have a look at the STL file. Just minimize that. Under here somewhere. Here we are, MeshLab. Excuse me. So if we open MeshLab and we stick our STL in here, so we've got our STL file. We can actually see what the STL file looks like. And it's not actually flat sides, although it looks like flat sides, it's actually made of triangles. There we go, I can turn that. So this is what the actual finished mesh, looks like. That's an STL file. It's made up of total triangles. They're all triangles with flat sides. And the way, it's better if we just put a bit of, put that on. So we can see the way this ends up a flat piece. It's the way it's drawn. This is supposed to be a fillet that's curved. Can you see the curved fillet? But the thing is, it doesn't put flats all the way across. And it's version 2 I'm using, so I don't know why it doesn't do that. You can see that actually in FreeCAD. Look at FreeCAD, it comes straight out of FreeCAD, does that? Can you see how it draws them curves? What it should be doing is drawing flats all the way across there, but it isn't. Don't know why. Anyways, that's another thing. So yeah, where was we? Yeah, so we can actually see that everything is made up of triangles. This is all how everything is drawn on computers and models and stuff. It's all broken down into triangles, even these flat sides. See, these aren't too bad, these, because these are pretty even. You can see that they're doing the flats even. But the way they do fillets is wrong. This fillet doesn't look too bad. If we look at this fillet in here, this fillet, that's how the fillet should have been drawn, and which is correct, because it's doing straight lines all the way across, and that fillet's okay. I don't know why this fillet has come out like it has. He's thrown a wobbler there somewhere. Anyway, so that's just what they look like, and then once we've done an STL file, I don't need this open anymore. Yeah, and then we go to it then goes to Cura, and then Cura takes the ST file and it redraws it, and what this does, it makes layers for printing. So we can look at those as well. So if we look at the layers, we can see that each layer is divided up, and if we just go down, you can see that well, if I go up there, then we can see better these ones underneath. That's the path that that's the path the printer is taking. So basically, then it moves along. What will that be? That'll be 0.4 millimeters. That there, because what you've got to remember, this is the red bit there, is the filament width, is the red bit. So you can see it's actually wider, and we're going to end up with a radius around this area here, where it changes from coming out, going across, and then going back in. This is the path, but because the filament is round, you end up with a radius on here, so you've got to allow for that. Let's just go back up to, well no, let's leave it at that. So if we go back to normal, although it's drawn it like that, this corner is actually going to be a radius. I don't know if the newer versions actually show what you get, but that isn't what we get. You've seen what we get in the camera. So the other thing is, when you're going to print something small like this, we've got this setting here. This one, fill density. So if we go down to layers again, we can see this yellow here, which is our fill density. And you can see that the way I've got it positioned, it's fairly even around the hole in the middle. If this was down, normally I usually have this at 10. So you can see that it's offset, but this fill density is worked out on where its position is on the actual table. It's not, this is not relative to the actual part model in this version, which is a shame really, because what I can show you what happens here is if we go back to normal, so I can move it, and if I move that slightly like this, and we go and have a look at that layer again, you see where these two bits are just touching that side. go back and move it a bit more. And now you can see that it's touching this side, but now going through the middle there. So if I go back to that and I try and move that to there, can you see we're now getting the infills sort of where we want them? So our infills there are now better. It's like that. So when you're doing a small thing like this, and you've got a hole in the middle, it'd be nice to have some stiffeners that actually go, you know, the infill act as stiffeners inside the plastic form, and they act as a reinforcement to hold this hole in place. So positioning your piece on the bed in a certain place helps with the infill. But what I usually do with something this small, and I want that hole to be solid, I want it more solid than it is, because what I'm going to do is, once I've printed this, I'm going to actually warm it up and reshape it, and I'll come to that. So what I could do is maybe go up to 20, and we go to something like that. That gives a bit more reinforcement around the hole in the middle. So yeah, so when you come to print it as well, it matters where you place it on your bed of your 3D printer. If you're using Cura, of course, I don't know how the others work it out. Some do different shapes. They do like the honeycomb shape and what have you. I think if I go into sort of special settings, I could probably change what that looks like. But anyways, it's just something I thought I'd show. It's just a little tip. And let's get back to my actual model. So I'll just move that out of the way. Don't need that, and we don't need this at the moment. Oh, right, yes we do. Right, well, actually, I need that, and we need that. So, yeah, let's go back to the wheel. So, like I say, when you first print these out, they're pretty crap. Well, no, they're not crap. They're okay. They'll do. And if you're making bigger wheels, it's probably not a problem. But with the smaller wheels, accuracy counts. So what I do is I've made a jig. So if we look at this wheel, well, tell you what. I've got some details of this motor. Have I got it zoomed right in? Oh, I'll leave it like that. Yeah, I'll leave it like that. Right, so this motor, where are we? This motor I bought, well, I thought it was a 24 volt motor. I've been sticking 24 volts in these motors. But actually, this is the data that I got off the web when I bought the motor. So it says 6 volts to 12 volts. 3800 to 7800. RPM is usually relative. Well, no load, no friction. The voltage will be relative to the speed. So get calculator. Yeah. So my calculator. So 3800. Double that to 12 volts. So that's for the 6 volt. If you double that there, you get 7600. So I'm guessing it's friction at the slower speeds that made it slower. If I went with the 7000, yeah, I want 78, or divide that by 2. You see, there must be a bit of friction there, so it should be going that fast. But like I say, what I'm doing is I can take it up to 24 volts. So if I take it up to 24 volts, it will be twice this. So what's that? 7, 8 times 2. So 24 volts, it'd be 15,000 RPM. Yeah, so this will be 15,000 RPM at 24 volts. Now, so this will go a little bit slower than that. So what I got, what did I say that was? Hang on, where's my spreadsheet? Got a spreadsheet up? No, I haven't. Spreadsheet. Right. So the ratio is 20. It's 70 divided by 20. Well, 22 divided by 70. So 22 divided by 70 equals that. So if we multiply that by what did I say? Yeah, 15,600. 15,600. Right. So we should be able to get the actual wheel going about just short of 5,000 RPM. Right. So yeah, don't need the spreadsheet. Don't need that. So that's our draw bot. Right. So yeah. So let's put some voltage in there, and let's just right. So I just want to compare. So if I turn this wheel, I don't know if you're going to be able to see it. It does have like a bit of a wobble on it, right? And we don't want that. I'm going to correct that, and I'll show you how to correct it. But this one here, this one shouldn't have a bit of a wobble on it now because I've corrected it. So this one should run really true, right? So we can see how true that runs by putting some voltage in. So what I'll just do is stick 4 volts in there. So we can see that it's running pretty true now. Look at the belt. It's the belt. It's running in a new groove. So I'll just up the voltage to let's say 10 volts. Right, yeah, so at 10 volts you can see it's fairly true now. So that's what we need to achieve, and if I put it on its side, there we go, we can see it spinning. I wonder if I just prop that up there so it doesn't spin on that wheel. Right, so, it's not going to fall over, is it? Right, so yeah, so that's at 10 volts. And if let's take it up to its 12 volts. Yeah, so 12 volts, that should be doing the motor should be doing sort of like 78 RPM, but yeah, so and that's doing a bit less. So let's see if I take it to the 24 that I've been using it at. So that's 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, oh, one more volt, 24, there we go, 24 volts, that should be spinning, the big wheel should be spinning around about 4,900 RPM there. So yeah, it runs fairly true with that. I'm quite pleased with that, and it's not skipping or anything, it's running. So I'll just bring it back down to 5 volts. There we go, it's back down to 5 volts. So yeah, a bit of optical illusion there with the thing spinning the wrong way. Anyways, it's all to do with the camera frame rate. Right, so yes, So how did I true up this? What we need to do now is how did I true up this wheel? Well, after I made a jig. I'll turn this off. I made a jig. Let's just put this out of the way for the moment, and get rid of that. Let's just pause this, and we'll just bring up my FreeCAD. And we go there. So I made a small jig. So we've got our motor, and at the moment I've got this printed timing wheel on there, and it's fixed to the actual motor, which is a good thing. So we know that if we make a jig that attaches to the motor, it's going to be relative to the timing wheel, what we want. So what I've done is I've done this jig. Let's just so this plate here, this actually bolts to the motor, and this has a hole in it. And then we have the wheel, and the wheel is shaped like this. So if I have this wheel that spins on that pin there, it should match these plastic shape here, but it won't. But what we can do is, once we get this turning and this turning so they all interact, I can warm this up, this plastic, and I can make it soft. Not too soft so it collapses, but soft enough so that we can actually manipulate the plastic and mould it sort of to a shape. This is made out of hardboard. This is not going to go soft when I warm it up. So when this warm plastic goes through these gears, these gears are going to reshape all these teeth to the correct alignment. So because it's all aligned on this flat jig, all these teeth are going to get aligned with these teeth, which are acting as the belt, basically. So let's do that, shall we? I'll show you what I mean. Let me just set that up. Alright, so I've got my motor, and I've mounted the flat plate on there, and I've got my wheel. Now my wheel has the pin through, and that pin there should be able to go into this hole here. But if we go like so, you can see, I don't know if you can see that, but let me just try and get that lined up so you can see. Can you see it won't fit? It won't fit in that hole because these teeth are actually pushing this away from there, so it's pushing it out that way. Pushing it out that way, and I need to push it further in now to get it in that hole there. But to push it further in, what I need to do is to warm this up. So what I'm going to do, just for the video, I'm just going to mount it on here, because I need 3 hands. I need 3 hands for this, so this is going to be my 3rd hand. What I'm going to do is I'm just going to mount that there with this clamp. Normally I would do this in the vise, but I haven't got the vise on video, so yeah, I would put the vise in, and then once I've got it started, I will actually add power to the motor and spin the motor with power with this in there, and just keep putting a bit of heat on and heat off. But what I'm going to do is I'm just going to just warm this up so I can get this fitted, and just turn it round by hand like this. So I'll just get it started, and then what I'll do is I will finish it off in the vise. But I'm afraid you won't be able to see that. So you may recognise this This is what I used to warm things up with. I've just repaired it lately. So let me just crack this up. Having a bit of trouble to starting it. Let me just get it started. I clicked pause to start it, and while I started it, and then it just started first time. So right, so just on a low power, I'm just going to add some heat to this and turn the wheel. So we're putting some heat into it basically. I just want to soften the plastic, but I don't want to soften it too much. I just want to soften it enough to get my jig in place. So hopefully that might be enough. Let's just find out. Yeah, so I can get that in, and I can turn this around like that. Now what I'm going to do next is I'm going to use my torch, and I just warm this up as I turn this until it becomes a nice flat, nice slack fit. Right, I'm just going to do this in my vise now. Yeah, but basically that's what I do. I just keep turning it until this cools down, and once it cools down, it's cooled down into the correct shape. Although the outside might still wobble a bit, the bit where the belt goes, this is the replicating the belt. The belt should run true inside the toothed gear, basically. So this is what happens. Then once it starts running, I can actually add power to this and warm it up, and it'll spin this itself, and a bit of centrifugal might just spread the plastic out into the teeth. You never know. Could be talking me out my ass there with centrifugal bit, but the theory's there. So yeah, I use this jig to set them teeth so the belt fits in it perfectly. Right, so I'm just going to pause and finish it off in the vise. Okay, I've done that timing gear. I've fitted it. It's time to make a belt now. So let's just zoom out a touch. Yeah. There we go. So I'll just move that. Move that up there, out of the way. And right, so our timing belt, well, I've already made one, so you can see I've cut a piece out of it already. Now then, I'm going to leave this end here with that number on it. You never know, I might be able to find it, because it's a nice small bit of belt. So the first thing is to measure one out, and I actually made a mess with the first timing belt. I said I was going to overlap 3 teeth, but I ended up only overlapping 2 teeth. But it's working, so I'm going to do this the same, just going to use 2 teeth. Now, you know the old phrase, measure twice, cut once? Well, yeah, definitely here. So what I'm going to do is I'll mark that as 1, and we'll count 10 and keep doing that. 1, 2, 3, 5, 6, 9, 10. And just mark it. Actually, you're better off at the other zoom level. Let's just see what it looks like. Yeah, there we go. Yeah, it is better like that, isn't it? Yeah, so like I say, I've done that isn't my mark. That one there. No. Yeah, so we do a count and do 10. So it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then we'll do the same again. 1, 2, 3, 6, 8, 9, 10. Mark it. And then we'll do a check. 1, 2, 3, 4. Yep, that looks good to me. And got that focused, I hope so. Let's just try. Wake it up a touch. Yeah. Yeah. Okay, so I'm going to keep doing that. So we'll just keep pulling it out and go 1, 2, 3, 4. Check that one. 1, 2, 3, 4, 5, 7, 8, 9, 10. 1, 2, 7, 10. 1, 2, 2, 3, 90. Yep. Again. 2, 8, 2. Yeah, you might wondering. Well, I got my ruler here, so I got my ruler. You might wonder why I'm not using my ruler, because we know the pitch is 2 millimeters, so it's 1 millimeter tooth, 1 millimeter gap. And if we want, what did I say? 88 plus 2, 88. Well, actually, I'm not sure if I did right. Anyway, doesn't matter. Maybe I should take the other. I might check. We could work it out and measure it by millimeters, but what I've found is the teeth on here are not quite 1 mil apart. If I line that up with the edge there, so can we see that? Yeah. So here, that is the 1 millimeter mark on the 70. So I put the tooth right bang on the between the 69 and 70 sort of thing. But if we look down here now, oh God, you put it on. No, there we go. No, I went too far. It's corrected itself. So as we move along, can you see it's like 1/2 mil out there and 1/2 mil out, and then it comes back again and it lines up again. So between there and there, it's actually moved 1 millimeter. It's out, so this is why I'm actually counting them. I've made a mess of that, haven't I? This stuff doesn't dry very quickly. Let me just get out. 1, 2, 3, 4. 1, 2. That's just. It's going to confuse me if I don't scrape that off. Can I scrape it off? I got ink on my feet. Oh shit! I'm just. Oh God. Just put ink in the palm of my hand as well. Yeah. Anyway, silver hand. Oh, in silver it goes grey, and it takes forever to dry as these pens. Right, so we've got 10, 20, 30, 40. Well, so we've got 1, 2, 3, 4, 5, 8, 10, 2, 3. Yeah, you can fast forward to when I cut this piece if you want now, because this is all I'm going to do. Is just going to 1, 2, 3, 4, 5, 6, 8, 10. 1, 2, 3, 4, 5, 6, 10. 1, 2, 3. I tried counting out all 88, and I got a different count every time. So this is why I'm doing 10 at a time. 1, 2, 3, 4, 5, 8, 9, 10. it's well, you know my memory. Get to about 50 and I forget where I am. Right, so now again, 1, 10, 2, 8, 9, 10, 2, 9, 10. We're up to 10, 20, 30, 40, 50, 60, 70, 80, 90. Right. Get rid of the... Oh, right. How many teeth did I say? 88, wasn't it? So we got 10, 20, 30, 40, 50, 60, 70, 80... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 8, 88. So that's the last one. So I've marked the last one fully, and I marked the first one fully. So they should stay. And then what did I do is I think I ended up with 91. Let me just check the other I don't know if there's going to be any markings on the other flywheel, on the other pulley left. Now I've spun it round at God knows what RPM. No, there isn't. But anyway, what we've got to do is end up like that. And I overlapped. Where is it? 2. Don't know if, can you see that? Yeah, I overlapped 2. I'm going to count these. Right, I'm just going to count these and check that I've got 88 on here. Let me just, because I'm sure I made a mistake somewhere, but I'll just pause while I count these ones. Yep, I've got 88 on that pulley wheel, and I've like I say, I've overlapped it 2. So 2. I want 2 extra. So there's my 88, and I want 2 extra, and I've gone. I want to go there. That's where I want to go. Fingers crossed. Right, so hopefully that's right. I've got enough for another go if I mess this up. Right, hang about. Right, so we need to cut this. So like I say, I'm going to overlap. So what we need to cut, I'm going to get my magnifying, my microscope, so you can see a lot better, and so I can show it a bit better. So just give me a minute. Right, there we go. We can see that now. So if we look on the side view, can you see that there's like a bottom layer and a top layer? Well, sandwiched between these two layers are some reinforcing, I don't know, nylon fibre or maybe could be carbon fibre, but between these two layers. But this is where we need to split it. We need to split it down this middle bit, this bit here, and we're going to go and take two off on one side, and then we're going to take the layer off on the other side. So there's my last one, so that needs to stay on there. So what I need to do is to remove these two. So I don't know how well this is going to work on camera, because I'm blind as a bat, and I need to see what I'm doing. Right, I'm just tell you what I need to get. What I normally do is right. So I get my ruler. So see my ruler like this. It's a steel ruler. And what I do is I just hold it under microscope, well, under my magnifying glass. This steel ruler gives me a bit of backing, and what I can do is I can cut like this. I don't know if I'm going to be able to do that. Let me just let me just rearrange some things and see if I can get it so I can, because I find it easier to do it like this than on the bench. Right, here goes. Right, I think I've got it so you can actually see it, and I've got it in my magnifying glass so I can actually see it. And basically we just start by chopping them two off there. Make sure you have a nice sharp knife. Although these are throwaway blades, I tend to sharpen them. You can get them sharper than what they come. So I hope I'm in sharpness. I'll have to cut this out if I'm not in shot. But right, so basically we get down to there. Just check that. Right. So can you see them brown marks? Those are actually the reinforcing strands or whatever they're made out of. Yeah, so that's what we need to clean it down to. So we need to take the rubber off and don't go past them lines. So basically what we're going to do, I'm going to do a cut where the other one ends, which is here, just slightly through, because we're only going to those lines. Then I'm going to come back and cut the rubber off bit by bit. Till I see these lines. We want these lines here all the way along our splice. And this a bit blunt, this one. Oh, there we go. Get that near the edge. There, can you see? Oh, I've cut one of them. But what we want to do is sort of stop at that level. So we still want the reinforcing on, because that's what we want to glue together. And that's what actually holds the belt together. Let's get the excess bit of rubber. The one good thing about super glue is it sticks rubber together really well. But anyway, I don't know if you can, let's see, let me have a look at the camera. Can you see how I've got it sort of down to the reinforcing, and I've removed them two teeth. So we've only got 88 on here now. So the other side, the other end, this end wants taking off on the back, and what I do is just bring it round, get it round that way like that. So this is going to go in there like that. Can you see that? So that goes like that. So what we need to do is just to have a look on the other side with them together. And can you see that the other one comes just at that point? I don't know. So we need to mark that point there, which is 2 in. And what we're going to... Did it go all the way? Let me just check that again. 2 in. It went right up to the third one. So what I need to do is I need to cut here slightly. Where nails come in handy. Don't want to cut all the way through, I just want to put a mark there. And then what we want to do is cut this side. Yeah, I'm still in the shot, I think. Right, so what we do is from that mark, which was there, is just cut down to the reinforcing again. Let's start where I need to finish it. So oh, there's the reinforcing. I don't know if you can see that. I just found the reinforcing, so I found my depth. I mean, it's best just cut a bit off at a time, because you go too far, you're giving after it. Right. Just going to pause a minute. Alright, so where are we at? Yeah, so I don't know if you can see that. Alright, I need my hand about there. Can you just see the reinforcing just start to show? So what we need to do is clear all that rubber off just above the reinforcing there. So, or on this side. Well, this end here wants to be like a square cut. So what I usually do is come in from this side, so I can come up to it, and then we can just trim it off. Just need to cut in. Where's that? Get my nail there. Get my nail the barrier. There, I can just see the reinforcing there, so just gently work my way to the end. Get it all nice and flat. Well, it doesn't matter too much with rubber. Rubber tends to sort of shape itself. There we go. Clean these little bits with nail. Yeah. Right, so that's got that. Can you still see that? Yeah, can you see the reinforcing that we've got down to? So that end's got that reinforcing, and this end's got the reinforcing on the other side, and they're going to go together. Right, let's stick these under the microscope so maybe you can see that better. Yeah, so there we go. So can we get that so you can actually see how the two are going to go together now? So they're going to go together like that. There we go. There's a slight jump, but we won't worry too much about that. We'll sort that out. There's nothing I can do about that because the way it's got to go. Let's zoom out a touch. Lift that up a touch. Oh, that's better. There we go. There you can see that. Well, I've gone down to the reinforcing on that side, and I've gone down to the reinforcing on this side, and then they're going to go together like that with a bit of super glue. But first we've got to get them lined up accurately, so let me just set that up and show you how I do that. Yeah, so yeah, let's get rid of the microscope. Well, actually I'll just move it to one side because we could maybe use it to look at the finished product. Right, so we've got our offcut still, and we need a load of clips. So we'll just get all these clips out of here, of my what is it? It's my cluttered bench. Right, so I've just got some of these little clips. So there's. Oh, let me zoom out a bit for this bit, so you can see a bit more. Yeah, so there's my cluttered bench again. So yeah, I've got arm clips. So this is the offcut. Right, I've still got a bit left, but obviously this has got all the teeth on in the right place. So we can use this as an alignment tool. So what we're going to do is we've got our prepped pulley belt, and this one's got the cut on the outside. What we can do is we can put these edge to edge. Can you see? Does that look all right? See if we can get that focused. Yeah, there. So they're going edge to edge there like that. So they'll go edge to teeth to teeth, and what we need to do is clip all that in place. Now where we're going to glue it, we're going to have to put a clamp. So we need to put our clamp a bit further back to hold it in place, and I prefer two, because if using two clamps will stop it doing this or this. We want to keep it lined up that way as well, so we're going to use two clamps. So what we're going to do first is put our clamp that's going to actually clamp the joint together. So our clamp that's actually going to clamp the joint goes, well, I'll do it that way, is going to go there. That's right over the joint, a bit either side of the joint. Let's put it on this so it sits straight. Right, so and then what we do is we make sure that this belt is lined up, so we want two more clamps on this side. So come on, piece of it. We make sure that belt is lined up like so, and because we're holding it in two places, it's going to keep it straight, he says. Get it straight. There. So I've got two clamps on this side, holding this straight. Make sure I've got it all lined up. That one needs to just go on a bit. Take this one off for now. There we go. So that's lined the belt up perfectly straight with the other one underneath. So the other end of my yeah, this is the going to be the pulley. We sort of have it inside out sort of thing, it doesn't matter. That there is going to sit on top of that one. But what we do is we line the teeth up with this spare bit of belt. And that way we know that the spacing is going to be correct. Just put that on there for the moment. Like that. And then we put two more clamps this side to hold it straight along this side. There we go. So that these four clamps are holding the belt straight and everything, and this one is the one that's going to actually clamp the joint together. So you can see that the joint there is now perfectly lined up when I straighten it up. So we can now add some glue. There's a bit of super glue. Here's this Gorilla Glue, and yeah, I just want to put a bit where the actual doesn't want much, just the smallest amount. You don't want to go over the top with super glue. The less there is, the better. And then we can line that up and stick this clamp on. There. And we'll just leave that for a few minutes while the super glue goes off. So I'm just going to pause. It should have gone off straight away because we've got the clamp on there, so that should have clamped the rubber together, and it should have made a good joint. But my tea and toast is alright, so I'll have my tea and toast and come back. So yeah, that should have glue should have dried now. Next step, take all these clamps off. Leaves us the belt. So at the moment it's into. So oh, I've got my wrong glasses on. I can't see what. Wrong glasses, and I wasn't wearing the mic. Right, so I know this when I change my glasses. So right, can we get that? Oh, let's see. Right, let me. I'll leave the clips there. Let's bring in the microscope and let's have a look at the joint. Yep, I need to bring up the microscope. Like that. There we go. Let's see, is that still working? It is. So, the down, is that in focus? Oh, there's a bit of muck there. That's a bit of rubber that I cut off. Right, let's just get that in some sort of focus there. In fact, actually, I'll just make it bigger and then. Right there, so where's the joint? The joint is there. Now then, have we got that in focus? That's in focus, right. Don't know if you can see it, but yeah, that's where it starts. Oh, there's a bit of crap there, so let's get rid of that. How's that? Can't see it. Right. No, well, I'll come back to that in a minute. Right, so it starts there, and then it sort of comes along and then down. You can see it better there. But let's just turn it the right way around. Right, so inside out anymore. Alright, there's the joint, if you can see it. But the only issue is, when making your own, is you've got a slight step here. But hopefully it'll sort itself out, that. Like I say, a bit of further. But yeah, so we've got it lined, the spacing's right, that's the important bit. What we do next is, oh, excuse me. See if I can get that under the microscope again. Right, so we're looking sort of down on it now. Right there. Can you see there's a slight, I haven't quite got it lined up perfectly. So what we need to do, and it's not so bad on the other side, but what we need to do is, that's going to click, is that. So we need to get rid of that. All I do with that is, let's just back, is I've just got a bit of flat white sand, bit wet and dry on there. Where's the joint? Plaster joint. There's the joint. Yeah, so I just hold the joint in, that right. Move that again. Let's zoom in. There we go. So I just hold the where the joint is in my pliers. Oh, we got that focused again. Let's get that. Come on. Oh, there we go. Yeah. So I just hold it in my pliers, so it's just sticking past there, basically. And yeah, just run over it with the emery. We got that right here. So just nice bit of flat emery. That gets it smooth in that direction. Basically, they just move away. It's the joint that you're holding with the pliers that actually gets most of the sanding off, and then it just feathers out as they give. So let's just turn it around the other way. Hold it in the pliers again, and then a bit of emery there. That's got it. Yeah, that should look smoother now. So with that done, and it'll look better now as well underneath the microscope. Let's bring that back in. Bring back the microscope. Get rid of my ruler now. Everything's got a place to go, otherwise you can't find anything. Right, where's the joint? Find the joint. Yeah, there it is. So, have I got that? Oh, it'd help if I have the microscope up, won't it? Let's go big again. Yeah, so there we go. So that doesn't look too bad now, does it? So, that's same on the other side. Where are we? I've lost it. Where is it? Oh, it's there. Right, there we go. Is that it? Yeah, that's it there. So there's a joint. So it doesn't look too bad. It's quite strong, is that? So back to there. Back to, let's zoom out a touch. And so now I can get rid of the microscope, I think. Well, just in case. And bring back the robot. So now this one. Right, so I've got these adjusted. Right, so, well, I've already adjusted that one there. So what I'm going to do is I'm just going to move that there and put it where the other one is. Should end up the same. Clamp that in place. Now what I have is a little pry bar, and I use that to just prise it one way or the other. So yeah, get that side. There we go. I should do that with my nails. But anyway, so I'll just nip these up a bit more. There we go. And then what I can just do is use the pry bar just to prise it back. And so that should just go on there like that, he says. Let's find out how well I've done it. I think this belt is stretched in places as well, but like I say, I don't know, can you see that? Can you see how it's lifted? It's lifted there, that's because I haven't got enough tension on it. So I'll just prise that back all the way there. Oh, it's a bit up twist. There, how's that? That looks about the same as the other one now. There's only one. It's not holding it there. I might have to do these bottom clamps again. I don't think they're tight enough. Alright, so that should be... There's only one way to find out, is put some power on it, isn't it? So let's just plug some power to the motor. And let's turn it on. Right, so this... Oh, I'm just going to knock the voltage down. So I'll start about 6 volts. Here we go. Alright. Doesn't seem too happy at 6 volts. Right, so let's just up the voltage to 9, 10. Right. May just need bedding in. Yeah, there we go. Right, let's just up it to, say, 12. There we go. It's at 12 volts now, and that's spinning, but it doesn't look quite good. That I don't think I've made a good job of this small timing belt. I might timing gear. I might make a new one and give it another go. But anyway, let's see what happens when we give it the full 24 volts. So here we go. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Right, if that doesn't sort out any errors, I don't know what will. But yeah, that's staying on there, but it's not as good as the other side, I don't think. There's still a bit of vibration there, so let's have a look on the top view. Is that one? Oh, I thought that was one. Right, so there's the top view. It doesn't look too bad, does it? I don't think this should be shaking as much. Well, it's not. Actually, it's getting better the more it's run. So I think it's actually bedding in there at 5,000 RPM. Yeah. Right, let's see if it'll run at the test is if the motor will run at the lower speeds. That's what we need to find out. Oh, hang on. I think I've just burnt the motor out. Oh dear. Oh, it is slightly warm. All right, hang on. Let's go down to the 12 volts. See if it's still working. I didn't like the sound of that. 12 volts. Oh, I think I've I think it was too much for that motor. That. Oh dear. Right, yeah. Oh right, I've just burnt that motor. I don't know if I've got another one. Yeah, right. It's time to strip that motor out. It's I'm kidding. Yeah, like I said, I should have taken that heed the warning there. 12 volts only. Never mind. So yeah, right. So it's repair motor time. Anyway, I hope you understand. I hope you was okay with the belt. I've made my own belt and it works great. You know, you can't really tell. Now that I've spun it around the gears, it's sort of... Well, actually, I can't find the start now. Oh, there's the start. Hang on. Right, let's zoom in on that. And you can see how it is now. Now that it's bedded in, and I've spun it round a few times. See if you can spot the joint. Yeah. So can you spot the joint? The joint is. Hang on, let me just check. Yeah, the joint is. It's where my mouse arrow is. There's the joint, and you can see. It's not too bad now that we've sort of given it some 5,000 RPM and burnt the motor out. Yeah. Right, so yeah, I'm going to sort of source some more motors now, and then we'll have to continue. So it will continue after I have. Well, it might be just the brushes on. Well, let's zoom out a touch. It might be just the brushes on. I'm hoping it's just the brushes on there. So I'm going to strip this motor down and have a look at the brushes and check them out, and I might be able to fix it. If it's one of the windings that's burnt out, then we're actually screwed with the motor. And I don't think I've got any more of these motors. I think these were my last two, and I can't remember what I did with the others. And they're getting expensive as well, these motors now. I mean, these were only like £2 or £3 a piece when they first came out, but now they're about £6. So that's how it goes. Freaking COVID, I guess it was. COVID and well, I might as well blame. No, I'm not going to go politics. No, but I'm sure we all know there is someone making quite a bit of a mess of things. Anyways, everybody wants to make a lot of money quick, don't they? So taxes and post and stuff. I'm rambling again. Right, well, I hope you enjoyed that bit as well. So yeah, so back when I have an alternative motor, or I've replaced it with the same type. Catch you later, guys. Oh, before I go, actually, I might do another video of stripping this motor down and see what mess I've made of it. Catch you later.